Hi there, my name is John Ryan, and in this video I'm going to tell you about Snowflake Caching, which is just one module in my Snowflake training course, Mastering Snowflake, Fundamentals, Insights and Best Practices. So here we go. Okay, so in this module we'll cover caching in Snowflake. And before we start, it's worth talking about what a cache is. A cache is basically just a faster way of delivering the data from faster memory or SSD rather than storage. And Snowflake does this automatically across all the hardware layers. Data is managed in the cloud services, compute and cloud storage layers. And in the cloud services layer, we have two caches, the metadata cache and the results cache. The metadata cache is automatically captured statistics, and the results cache holds the results set of queries that have been executed. In both cases, you'll get millisecond latency. The compute layer, that's inside your virtual warehouses. We call it the data cache, and it's really raw data. And it's in memory and SSD, which means it's much faster than the slower disk. The size of that cache depends upon the warehouse t-shirt size and the number of servers that are deployed as a result. Finally, data is stored in the cloud storage layer. This is where your data is permanently stored on disk, which is relatively slow. However, it's massively scalable, virtually infinitely. So let's think about how queries are executed to maximize query performance, and then how the cache actually works to improve that performance again. Some queries can be executed in the cloud services entirely in the metadata cache. As I said, in the metadata cache, we hold the number of rows, the minimum and the maximum value of every micropartition, and so therefore selecting the min or the max of any numerical character column or the count, that'll come back instantly. And how it does it is when you execute your query, if it can be handled in the metadata cache, the data is just immediately returned within milliseconds. You don't even need a virtual warehouse. If it's suspended, it will remain suspended. And normally about 10% queries would use the metadata cache. So as an example, if you select the min, the max and the count, if you looked at the query profile, it would say metadata based result. It will have completed in a few milliseconds. If the query can't be resolved by cloud services, then it's executed in a virtual warehouse. So let's say we've got a query here that's selecting and ordering by and grouping data. Well, when the query is received by cloud services, metadata holds the pointers, knows exactly where in the physical storage the data is held. And so the candidate micropartition metadata is distributed across all the available worker nodes. Each of those will parallel fetch the data. Because the warehouse is just being resumed, it'll fetch data from physical storage into SSD, where the results will be calculated and sent back to the user via the results cache. The results are likely to be much smaller than the full set of data, especially because most queries on Snowflake tend to aggregate or summarize the data, and then that data is returned to the end user, but it remains in the results cache. This means that if the exact same query is executed within 24 hours by any user on the entire account, well, provided the results have not changed, those results will be serviced from the results cache. Your query profile will show query results reuse. There's no warehouse needed, and you'll get millisecond latency. I've benchmarked this to see what the impact of the cache on query performance, and here's an example query. The diagram on the right illustrates what the code on the left is doing. It's joining the region table with 5 rows, nation, customer with 150 million, and the orders table with holding 1.5 billion rows or 48 gigs of data. Now, to put this in context, we're also limiting by an order date, so we're only taking a month's worth of data, so it's not actually going to process all 1.5 billion rows. But the key point is not the query performance here, but the difference each time it's executed, showing the cache differences each time. So the first time we executed it, there was no cache usage and it took 4.3 seconds. So we can see here in the query profile, the total execution time is 4.3 seconds, and there was nothing scanned from the data cache. The second time the data query was executed, its execution time is now down to 3 seconds because 98.5% of the data was actually from the data cache. So it's now executed it faster. And then finally, if we execute exactly the same query, it comes back in 51 milliseconds because it's come back from the results cache. It doesn't actually need to go down to the warehouse at all. The rules in terms of how these caches are maintained, the metadata cache, it's automatically maintained. Effectively, as data is loaded into Snowflake, the statistics are automatically captured. You don't need to capture table statistics at all. And we're keeping the row count, min-max values of numbers, dates, characters, that kind of thing. But you can't resize or clear the cache. The metadata cache is always going to be there as long as the data is in there. The results cache is automatically managed. It's effectively infinite in size. It's going to scale out and will only be used if you execute exactly the same SQL text. If you change the text at all, it's going to be executed on a virtual warehouse. And of course, if the underlying data is unchanged, if the data's changed, it will go down to the virtual warehouse and recalculate the results. If that data is not fetched again for 24 hours, it's aged out of the results cache, but every time that query results cache data is used, the clock is reset. And in fact, it's held in the results cache for up to 30 days, after which it's then cleared. The data cache is data read from the physical storage. Data read from physical storage is purely the columns needed, because Snowflake is a columnar database. Again, it's automatically managed. The overall size of that cache depends on the t-shirt size of the warehouse. In this, we've got 4 servers, so we've got 4 times the cache, and each increase in t-shirt size is going to double the cache size. Unlike the other caches, this is aged out on a least recently used basis, and we'll talk about what that means in a moment. And that cache is cleared when the warehouse is suspended. So provided the warehouse is up and running, that cache will still be fresh, and other queries, regardless of which user are executing them, will be executed using that data cache. One final point, the cache is never shared, never transferred across warehouses, and it's never shared across the nodes either. So let's do a deep dive into the data cache and see how that really works under the hood. The storage inside a virtual warehouse is solid state disk and memory, which is very fast, thousands of times faster than physical storage. As I said, the size depends on the t-shirt size and it doubles. So that means the larger the warehouse, the more cache you have. It's held on a least recently used basis, which means that when data is fetched from the cache, it's always moved up, and newly inserted data is held in the recently used area of the data cache. That means that as data is inserted, it's in the top. As it's then queried again, it's moved back up, which means gradually it's pushing data down to the bottom of the cache that's not being used frequently, hence the name LRU, or least frequently used. And any updates will invalidate those, and so they're automatically aged out as well, along with data that's no longer needed. It's in the least recently used entry. When a warehouse is suspended, the data cache is cleared, and then subsequent queries that can't be satisfied by the cloud services, metadata or results cache, they are going to need to go down to the warehouse, which will then retrieve the data from storage. You can set the auto suspend on a virtual warehouse. I would always recommend, in most cases, the virtual warehouse is set to 60 seconds auto suspend, because otherwise you're going to keep the warehouse up and running and billable when there's no queries executed. And we've found that the data cache doesn't really make that much of a difference to query performance. The results is that in order to preserve the data cache, you're going to maximize query performance, but in reality, don't get hung up on this. All of this caching is happening automatically. You can't really influence it, and I would simply leave your auto suspend time down to 60 seconds. So we've now got a hands-on lab, so you can try this out and get familiar with how Snowflake is caching the data and how you can switch off the results cache. And I'll see you in the next module. As I said, this module is just a small part of an entire Snowflake training course by me, John Ryan, at Analytics Today. It covers a huge range of subjects, and I'm happy to deliver this either as pre-recorded self-paced training or as a live instructor over 3 days. So if you or your company are interested in some of the best Snowflake training available, just like this video, you need to visit my website, and don't forget to like or subscribe to this video and get notified of new material. That's www.analyticstoday. Let's talk soon. Thanks.